It's by Professor Szymanski, also 50 years of, maybe less than 50 years, long-term friendship and collaboration. I think it's a video, right? Video presentation, pre-recorded. Break, just break. Okay.
Dear friends and colleagues, ladies and gentlemen, I'm grateful to the EAC 2022 conference organizers for providing the opportunity for the commemorative session to honor a special person, Professor David Puy, for half a century of research and service to the aerosol community and consequently to the wider society. I feel honored and happy to make a small contribution to this event, particularly because it is celebrated in Taiwan, a place where I spent several months in the 1990s working together with Professor Chuan-Jin Tsai at the NCTU. Well, it all started with aerosols. I was very privileged and lucky to work with extraordinary aerosol scientists. Professor Ottmar Preining was my PhD advisor at the University of Vienna, and he brought me together with Professor Benjamin Liu. He eventually offered me a postdoc position at the University of Minnesota, which I gladly accepted. However, Professor David Puy, it was him who welcomed me in 1983 at the University of Minnesota, and from the first minute there, he was a guide, a collaborator, and a true friend. I can say that David Puy is a friend for life. He is also an excellent scientist, a gifted experimenter and inventor, as well as a wonderful companion in various extracurricular activities, some of which I will share with you today. A quick glance back how David's and my way crossed. As a student of physics at the University of Vienna, I was looking for an interesting topic for my PhD thesis and talked in 1978 with several possible supervisors. One of them was Ottmar Preining. He convinced me that what I really wanted was a PhD thesis related to aerosols with him as a supervisor. After I agreed, he gave me some reading material, few papers, and a blue book with the title Experimental Studies of Diffusion Charging of Aerosol. It was a PhD thesis by David Puy. This was my very first encounter with David, and it was over 40 years ago. Here on the left-hand side, you see the first page of David's PhD thesis, which he submitted to the Faculty of Graduate School at the University of Minnesota. On the right-hand side, you see a diagram from his thesis showing the ratio of charged and uncharged particles versus particle diameter, and note the exceptional experimental data he measured down to 20 nanometers already in the mid-1970s. The story is unfolding. In 1979, scientists from various institutions, particularly from the University of Minnesota, arrived in Vienna for the workshop on ultrafine aerosols called WUFA. In fantastic 2 weeks of laboratory experiments and discussions, the aerosol electrical mobility classification was firmly established as one of the most important methods for particle sizing and for particle measuring instruments calibration. During the WUFA, it was the first time where David and I met in person. It was a busy and satisfactory period, resulting soon in first papers where David's name and mine were on the same page. Here on the left-hand side, you see from one of the papers a result of our work during WUFA, where we measured the performance of various concentration measuring instruments versus aerosol electrometer, a fact to which I will come back later in this talk. On the right-hand side, you see a result of a very interesting experiment where we ran the University of Minnesota DMA versus the size analyzing nuclei counter, an instrument which was developed at the University of Vienna in the course of few PhD theses. And we measured here the Kelvin equivalent diameter. The red arrow shows you the nominal particle size in the diagram, the measured distribution with the Sank. It's a very good agreement. Well, in the summer of 1983, I arrived at the U of M as a postdoc in the particle technology laboratory. David Pui welcomed me at the airport in Minneapolis, asking me at my arrival if I were interested in to see some experiments. Of course, I said yes. By the way, this is how the Minneapolis airport looked like in 1980s. I was excited to see the famous particle technology laboratory, but instead to the U of M, David took me to the industrial scale coal gasification facility, where at that time he conducted some research. It was a hot-head area, dusty and hot, a bit of surprise, because it was not the imagined outstanding PTL facility. However, I met there a few people, and as a result of our future work was a contribution which was on the performance of electrostatic precipitator for tar removal in the coal gasification facility. Well, finally, David took me to the PTL at the U of M in the famous address, which you see here, 111 Church Street, Southeast. Well, this is how the entry to the building looked like. It was summer 1983, pleasant plus 25 degrees C. Well, Minnesota has two seasons. Well, one of the seasons is the winter. So in the winter of 1983, we had a pleasant minus 40 degrees C, which means that maybe because of the winter time, we stayed long hours in the PTL and worked. Here you have a glance in my working area at the PTL from 1983, and at that time, we were able to measure electrostatic effects in aerosol sampling and filtration, which resulted in a paper. Please note the enormous amount of data in the diagram, which we gathered from publications in the Wilson Library and not by just Googling around. Here you have a diagram for another paper, which David and I co-authored. We were able, with our experiments, trace the Me theory of light scattering, showing that the OPC response can be multi-valued and that the lower limit of the detection depends on particle material. There were also some other optical instruments to measure particles in vacuum. One of those was the HYT PM100 monitor, an instrument which was at that time very important for the microelectronic industry. But eventually the winter was over. And the whole crew from the PTL went together with David to the Boundary Waters Canyon area. This is the wilderness of Minnesota. In this picture, you see our whole team. On the left-hand side, of course, is David, who was the head of the group. Then the next person is Mark Stolzenberg, Dan Rader, Tom Cox, Sean Smith, Orville Lanto, myself, and Ken Rubo. When you look at the group, I wonder what would be the summarized science citation index of the group. I think it wouldn't be too bad. Well, it was a great outdoor experience. We went on the Gunflint trial, and the picture shows you how beautiful this area on the border between Minnesota and Canada is. Well, to get into this area, you need to have a permit because it's very limited access. We were there camping, cooking for us, and canoeing. Obviously, David takes the picture because he's not cooking with us together. And sometimes you have to carry the canoe from one lake to another. Well, let's go back to aerosols. I would like to point out remarkable links between two outstanding experimenters. Both were investigating electrostatic phenomena. One of them is Michael Faraday, who invented the Faraday cage. In his legendary experiments, 1836, Faraday applied high voltage discharges from electrostatic generator to strike the outside of a cage. It was actually the whole room, where inside were some instruments to prove there is no electric field inside. I hope there was not a person, but there is no record on that. The other one is David Puy. You see here, below his picture, a Faraday cage. David Puy in 1974 showed that putting charged particles into Faraday cage delivers absolute aerosol number concentration measurement by measurement of the induced electric current. In the meantime, the Faraday cage, or Faraday cup as it is named, became an indispensable electrical aerosol measuring instrument. Well, during my years in the PTL at the U of M, David taught me in practice what Michael Faraday once said: work, finish, publish. Well, David, we worked together, we traveled together. Our daughters had fun together. In the 50 years of David's activities in the aerosol science and technology, he became a role model, not only for me, but to many scientists worldwide, creating research and friendship as inseparable merits. Thank you, David.
It's another touching story.
I would like to thank you for the opportunity to share with you my memories, how the aerosols became a link between myself and David Puy, and I wish you a very successful conference. Thank you and goodbye.
Thank you, Radek. It's not online. Oh, yeah.